Okay, so for this lesson, we are going to talk about two types of events. And these are a little confusing, so if you have this available, it will be very helpful. So the first type of event is called mutually exclusive. And so think of the word exclusive, and that means only, okay? And so for mutually exclusive, we are talking about two events that cannot occur at the same time. So on these probabilities, you will still just be picking one thing, but you'll have a couple of topics or subjects or options. And typically you see the word or in the question, okay? And so you need to ask yourself, can there be events that happen at the same time? If the answer is no, then those events are considered mutually exclusive. So before we get to the formula, let's look at the examples. So example 1, we are rolling a 6-sided die and we only roll it one time. That's the key. It says, what is the probability of rolling an odd number or an even number? So see, if we had the notation, it would say odd or even. So you ask yourself, can we have an odd and an even number at the same time if we roll a dice one time? And the answer is no. Okay? Let's look at the second example. If we take the letters in the word school, it's asking us for drawing an S or an O. So you ask yourself, well, if we pick one letter, can we have an S or an O at the same time? And the answer is no. In quarter 1, we did Venn diagrams. And so when we had two separate Venn diagrams, we knew they had no outcomes in common because the circles did not overlap. So once again, the key is that you're only picking one thing, and so you ask if those topics can happen at the same time for that one pick. So if two events are mutually exclusive, when we have the word or, what we do is we add up each of the probabilities separate. So let's look at the letters in the word school. So if I wanted to find S or O, if I was doing this, I would find the probability to pick an S, and then I would add the probability to pick an O. So on an S, we've got 1 out of 6, plus O, there's 2 out of 6. And so altogether, we end up with 3 out of 6, which is also 1/2. And that would be our probability. So for mutually exclusive events, you add each of the probabilities together, or you count them up, however you want to think of it. All right, the other type is not mutually exclusive. And so two events are not mutually exclusive if they can happen at the same time. Once again, you're only picking one event. Okay, so we're just picking one thing at a time. But we're going to have a couple of different categories. So let's look at similar examples. So example 1, a single die is rolled. What is the probability of rolling a 5 or an odd number? And so you ask yourself, well, can we roll a 5 and an odd number at the same time? Well, let's think. The odd numbers are 1, 3, and 5. And so you can see I've listed it twice. So yes, 5 is odd, so they can happen at the same time. So this would be not mutually exclusive. Cards. I know a lot of you aren't familiar with playing cards, but if you are, these problems I avoid on a quiz, but they are the best problems to illustrate these two ideas. So if we pick one card, it says, what is the probability that we will pick a club? So those are the clubs, they're black, or a king. And so there is a card that is the king of clubs. They can happen at the same time. So that's why these are not mutually exclusive. And if you're looking at a Venn diagram where the two circles overlap, that's when the two events happen at the same time. Okay, and so that illustrates in a picture what not mutually exclusive means. So if we are calculating these events, you still take each of them separately and add them together, but this is when they happen at the same time. So let's look at the die. Okay, so I'm going to go ahead and write this a little bit smaller. So if I wanted the probability of getting a 5 or an even, odd, so let's say I couldn't just count up some of these events, the formula would be useful. So we're going to pick what's the probability to get a 5, what's the probability to get an odd number, and then we have to subtract when we counted it double. So the probability to get a 5 and an odd at the same time. So the probability to get a 5, well, there's only 1 out of 6. The odd numbers were 1, 3, and 5, so that's 3 out of 6. And then how many times, oops, that's a 6. How many times can they occur at the same time? Well, you could only have a 5 and an odd at the same time because 5 is odd. So that happens once. So if we do 1 plus 3 is 4, 4 minus 1 is 3 out of 6, which is 1/2. Okay, and so this is the key. You need to subtract when they happen at the same time. So let's do some examples. So first, we just want to identify which ones are mutually exclusive or not. So remember, mutually exclusive means cannot happen at the same time. I know the words are confusing. That's why I write this out every time. So not mutually exclusive means they can happen at the same time. All right, so let's go through the examples. This says which ones are mutually exclusive. So which ones cannot happen at the same time. So if we pick August, we're picking a summer month. So let's just classify. We're going to say December, January, and February. Those are fall months. We got March, April, May. Those are spring. June, July, and August. Those are summer. We need to clarify in case anybody has different definitions. And then September, October, November. I wrote the wrong thing up here. This is fall. I meant to say winter. Okay, so let's see. If we pick August or a summer month, can those happen at the same time? So here's August and it is a summer month. So these can happen at the same time. And so that is not mutually exclusive. Let's look at the second choice. Picking September or choosing a fall month. So here's September and fall. So those can happen at the same time. So that is not mutually exclusive. Choosing a summer month or choosing a winter month. Those cannot happen at the same time. Those are two different seasons. And so that would be mutually exclusive. Okay, so see how you have to kind of keep that in mind because it's not what your brain wants to think. The word not is very tricky. All right, so let's find some and classify at the same time. So you are picking a day of the week at random. You're only picking one day. What is the probability of picking a Monday or a Wednesday? This would be how we write it in the notation. So first we need to figure out, can they happen at the same time or can they not happen at the same time? Well, a Monday and a Wednesday, those definitely cannot happen at the same time. So our formula says to find each of these separately and add them together. So there is 1 out of 7 days that is a Monday and 1 out of 7 days that is a Wednesday. So our probability is going to be 2 out of 7. All right, let's try another example. So the probability of a New York teenager owning a skateboard is 0.37. If they own a bicycle, it's 0.81. And if they own both, it's 0.36. So first, we want to know what's the probability that we own a skateboard or bicycle. So first, let's figure out, are they mutually exclusive or not? So can we own both at the same time? Yes, we do, 0.36. So yeah, we can own both. And so because we can own them at the same time, these are not mutually exclusive. So our formula says to find the probability of a skateboard, add the probability of a bicycle, and then subtract when they happen at the same time, owning both. And so this is one where we'd have to use the information given because we can't just logically think about this. So the probability of owning a skateboard is 0.37. Owning a bicycle is 0.81. And owning both is 0.36. So if we calculate all of these, I'm going to go ahead and use a calculator. We get 0.37 plus 0.81 minus 0.36. And I got 0.82, which means 82%. So really, you're just taking off how many you're counting in both groups in the first two. All right, let's do another example. You are rolling one six-sided die. So 1, 2, 3. And for some of these, you might be able to list them out. And so you don't have to use a formula. It really depends on the scenario. What is the probability to roll a number bigger than 3 or an even number? So let's classify. Can these events happen at the same time? Can you roll a number that's bigger than 3 and it is also even? Yeah, 6. 6 is bigger than 3 and 6 is even. And so because they can happen at the same time, if you are using the formula, you need to take off when they happen at the same time. So we would take the probability more than 3, the probability of even, and then we subtract off when they happen at the same time, bigger than 3 and an even number. So I'm going to list these out so you can actually see. So the numbers that are bigger than 3, we've got 4, 5, and 6. So that's 3 out of 6 choices. The even numbers are 2, 4, and 6. So we also have 3 out of 6. And how many numbers are bigger than 3 and even? Well, 4 is bigger than 3 and even, and 6 is bigger than 3 and even. So we've got 2 choices out of 6. So 3 plus 3 is 6. 6 minus 2 is 4 out of 6. That also reduces to be 2/3. I do have non-reduced fractions as answer choices. Okay. Now, I wasn't using my formula. For die problems, you might be able to just figure out how many you have. So if I want to count all the numbers that are bigger than 3 or even, I can count all of these because those are bigger than 3. And then anything else that I have not circled, if it's even, I get to circle that also. So I already have 4 and 6 circled, but 2 is also even. And so you can see I've got 1, 2, 3, 4 out of 6. And that's what we found. So for some events, if you can just list them out and count, that's okay. But you saw the last problem, I have to use a formula. Okay? All right, let's try one last problem. So we've got 30 students, that's my total. There are 17 boys and 13 girls. On a unit test, 4 boys get an A and 5 girls make an A. If a student is chosen at random, one student, we want what's the probability that we will pick a girl or an A student. For this one, It's pretty complicated. I really do like using the formula. So first thing, we need to figure out, can they happen at the same time? Are there girls that also have A's? And so it says, yeah, 5 girls made an A. And so because they can happen at the same time, that's not mutually exclusive. So we're going to find how many are girls. We're going to add how many total students get A's. And then we're going to take off how many are both girls with A's. And that's how we would use that formula. If you use this formula and you don't have any that are in common, then that's okay. You would just be left with the first two. So when in doubt, I would say write out the formula, and if you just end up with a 0, it's okay. So how many are girls? Well, we have 13 out of 30 total. How many have A's? Well, we have to add boys and girls. So 4 boys and 5 girls have A's, so that's 9. And then how many are both? How many girls had A's? Well, that's 5. So see, we counted 5 in this group and we counted 5 in that group. That's why we have to take them off once. So 13 plus 9 is 22. 22 minus 5 is 17. So 17 out of 30.